computer is taking its darn time. I'm going to blame it on the computer. Might be the internet. I don't know. So our calendar today, we're going to start, actually, we're going to start here talking about light and how we calculate energy of light. And then we're going to do a review on how to use your calculators, because there's still a lot of people that aren't using their scientific calculators or aren't using them correctly for scientific notation. And so you're going to get the wrong answers, even though you know what you're supposed to be doing. So I want to go over that with you. I'm going to have some office hours tomorrow. I'm thinking 10 or 11 o'clock. I'm not sure what works better for you. If you have a strong opinion, let me know. Just so all the classes can come with calculator questions. So I'll probably put a Zoom link out later this afternoon when I set a time. If you have a strong feeling, let me know. Again, mornings I have meetings, and afternoon at 3 I have meetings. So depends on the meetings, whether it's 8 or, well, actually, whether it's 7, 8, or 9 in the morning, and then always at 3 on Wednesdays. So let me know if you have a strong feeling. Yesterday I gave you the electromagnetic spectrum slide deck review activity. Some of you little red hots got it done already, so congratulations, but make sure to check your work too. Yeah, so that's the calendar. I apologize. There's 3 different things today. I'll explain why in a minute. First one is the note sheet, which looks like, oops, this. Sorry, I forgot to take that off, and then I was demonstrating something. We're probably only going to get to here. No, we're not going to talk about quantum mechanics just yet. But this, again, is just a follow sheet for you and a review sheet. This yellow area, you got to know. This formula, you got to know. And how to calculate energy, you have to know. So that is there. The other 2, this is a kind of a slide deck. We're going to use this when we go into breakout rooms today. This is a slide deck on using your calculator. There's the presentation within a presentation, and I made a copy of both. I got this from another teacher. However, someone in my second period said they couldn't access this second one. So because of that, I put together this great big list of different calculators. So depending on your calculator, the one that you have available to you, and again, you can't use your phones, okay? Yes, there's a scientific calculator on your phone, but you can't use those in my class, okay? So also, when you have to take like the SAT, if you end up taking that, or testing in college, they won't let you use your phone because, duh, you can get on the internet. So you need to know how to use a calculator and use it correctly. So pick the ones that make the most sense to you. Use the style that you have. None of them are very long. I think the longest one's 5 minutes. So find the calculator and then bring me your questions tomorrow during office hours. So that's that. Yeah, we're going to pick up here with notes, and then we'll go talk some more about calculators in just a few minutes. So take notes on your own paper. You don't have to take notes on the note sheet. Do not turn the note sheet in. It's not an assignment. It's ungraded. It's for your benefit. Where we left off yesterday was talking about electromagnetic radiation and how the electron and the hydrogen atom can make many different transitions. When it does that, the bigger fall it has, the more energy that's given off. okay, because it took more energy. Its normal position is in what we call the first energy level. It took more energy to get it to the 7th energy level. When it goes back to its normal state, it loses all that energy that was put in, and that comes out as a certain type of light, electromagnetic radiation. So Passion looked at the very smallest transitions. Those turned out to be in the infrared radiation area of the spectrum, longer wavelengths with lower frequencies and lower energy. Balmer looked at the colors that he could see with the spectroscope. They are in the visible portion when those electrons dropped from the 7th to the 2nd, the 6th to the 2nd, the 5th to the 2nd, the 4th to the 2nd, etc. Okay, so those transitions are longer, bigger energy than these, but not as long as these. So that was in the visible light. And then Lyman was looking at the ultraviolet energy. So all of this has been documented. And also at the same time, there was another scientist named Max Planck, who was working with solids and noticing the effects and trying to quantify the effects that cause colors on different solids. So again, you've seen your toaster probably, or the coils on an electric stove change color as you heat. The picture of the horseshoe that I showed you that's in our textbook, different colors correspond to different temperatures. Why was that? Well, it turns out it's because of electrons, but Planck is famous for calculating how much energy to get to these certain colors. And he came up with this equation, E equals H. It's not a V, that's nu, the Greek letter, lowercase n. An n for number of waves, right? Frequency is number of waves per second, hertz per second. This little h is a special little fudge factor. So E is for energy, just like in Einstein's equation, equals mc squared. This is E equals h nu. And the nu is just like what we've been talking about, the frequency of the light, electromagnetic radiation, all of it we kind of call light. H is a little, really little, tiny number, little fudge factor that you need to make hertz into joules, okay? Look how small this is, 10 to the minus 34th. That's ridiculous, okay? It's just a little massaging of your measurements to get it to be equivalent, okay? Measure frequency, multiply it by this little tiny number to get energy. And 6.6262 times 10 to the minus 34th sounds like it's impossible to memorize. You'll be surprised how well it will stick in your brain. 6.02 times 10 to the 23rd, you know, numbers that you use a lot will end up staying up in your noggin more. So joules, and notice it's not per second, it's joules times seconds. Anyhow, we're going to do some calculations with those, okay? So this is that yellow part that's on the note sheet, the highlighted area, the take-home message for today. Radiation that's emitted when an electron moves down to a lower energy level. That frequency of that light is directly proportional to the energy. So remember, we've been talking about wavelength is inversely proportional. Long waves, low frequency. Short waves, high frequency. They do the opposite thing. One gets bigger, one gets smaller. With energy and frequency, they do the same thing. Higher frequency, higher energy. It's kind of intuitive, right? You want to make something move faster, more waves per second, you got to put in more energy. Makes sense? Okay. I mean, it kind of makes sense. Except for the part that we're talking about electrons and atoms. But anyway, so electromagnetic radiation, higher frequency, purple, it's going to have higher energy. And this is just representing, now these rings should not be concentric. Okay, they shouldn't be They should be spaced differently, but it's okay. So here's an electron excited at the third energy level, falls down to the second. It's going to give off a wavelength of light that we can measure its frequency and calculate its energy. Okay, so delta E is this change in energy, H is Planck's constant, and nu, not V, is the frequency. All right, let's talk about calculators. So hopefully you've got your calculator, your handy dandy trusty dusty calculator next to you. Again, this slide deck will help you with basic scientific notation. It won't help you as well as the videos will for entering numbers that are already in scientific notation. This lady, Nikki Wilkinson, made all these beautiful slide decks that I've been sharing with you. She shares them for free on the internet. This third page we'll look at together in the breakout room, but let's look at our calculators first. Of course, I have to find the thing. Oh, it was right there the whole time. Okay. So I made this for each of you, but like I said, if you tap on this, oh, there it is. I guess you can't access this next one. So let me just show it to you real quick. Well, maybe not so real quick. As slow as my internet appears to be going, it must sound terrible on your end. I apologize. So these are 3 different Texas Instrument calculators. A lot of you have this one, I'm pretty sure. I don't know how many of you have this middle one. And then this one on the end is a TI-83. I don't think they make them anymore. Most of us have TI-84s. And some of you might have the skinny color ones, like my kids do, my children. But if you click on a particular calculator in this deck, if you could get into it, it would bring you to the appropriate slide to switch from regular notation to scientific notation. Little trick may be useful, maybe not. You can press the second button and then press the DRG button. When you do that, this will appear in the screen, flow, psi, no. You want to highlight the arrow over using the little arrow buttons on the calculator and then hit the enter button to get it into scientific notation. The awful thing with these early TIs is that, and most of them still, I think, they don't put in times 10, okay? If you're lucky, they put in an E. This one doesn't even have an E on it. It looks like this number to the -1 power. It's not what it is. Okay, it's this number times 10 to the -1, which means the decimal moves over 1 place to the left. If you want to get out of scientific notation and just have normal numbers, you hit that second DRG button and cursor over or arrow over to flow. Okay, I'm assuming this is correct. I don't have one of these of my own. This is the video on how to input numbers. And there's a specific way that you do that on these calculators. And so you need to pay attention to how to put numbers that are already in scientific notation into your calculator. Okay? It's really important you know how to do that. This calculator, some of you might have it. You can switch back and forth between regular notation and scientific notation. This is a ridiculous number. 1.234567890 to, it looks like to the 99th power. Again, this should be base 10 in here, but it doesn't put it in the display. On this calculator, it's easy to put numbers in scientific notation. You type the coefficient, hit the EE button, and then put in your the exponent, the power. But you can also do second 5 and switch it to scientific notation. You can also do second 4 to get it into standard notation. So you don't have to do the degree thing. This is a quick one on putting a number that's already in scientific notation into your calculator. TI-83s and TI-84s work the same way. They just look a little different. So first thing you have to do, of course, is turn it on. There we go. Blinky, where are you, Blinky? There we go. And the next thing you have to do is push the mode button. When you do that, you'll see a big list of things. And across the top line, it says normal, sci, and engine for engineering. And you want to arrow over if you want to put it always in scientific notation. Arrow over to the sci, so it's blinking over SCI, and then hit enter. Any number then that you put in 2000, after you go back. So 2, 3, 5, 6, 7, 8, 9 will automatically, whatever you put in normal notation will automatically go to scientific. You can get out of that by pressing mode again, arrowing back to normal, hit enter, second quit, and go home. And it'll stay in normal notation. Now, to put numbers that are already in scientific notation into these calculators, you need to use the second EE buttons. So 6.02. Hit the blue second button. The EE is above the comma, which is above the 7. It plunks in a capital letter E. That means times 10. And then you can put 23 and enter. I have mine set. Another thing you can do is if you look, the second line is float, and I have mine set for a lot of digits. So I think it's on 6 digits. 5 is probably enough, but I like to have it so that I can do my own rounding. Okay, 1, 2, 3, that's really not enough. At least 4, preferably 5. I'm gonna leave mine on 6, okay? That gives you how many digits it goes out to. All right, so those videos, I know you don't have time to watch those right now. That's fine, you can go back and do that on your own. The other thing I just want to mention real quick is this has an explanation on how to put things into scientific notation in Google Docs. So on our Google Doc that we were looking at, I'm going to cursor down again and cursor up, and the blue little doc symbol, file, edit, view, insert. If you scroll down to where it says special characters, you can switch from, I think it starts off with arrows. So you can go to math, and then it puts in pluses and less thans and divisions and plus minuses and multiplication. So that will input what you need. So let's just do the 6.02. And then again, insert, special characters, make this to math, hit the multiplication button, and it'll show up next to your text. And then you can put 10. Whoop! So you can't, I lied. You have to get out of here first. There we go. Then do 10. And then to do powers, you can do format, text, superscript, but that's a lot of work going through that bar. If you can find the command button on your keyboard and the period and hit that. Let me go back here. Command period. Notice the cursor jumped up half a font width, height. You can type 23, but you have to do command period to get out of that. Okay, so hopefully, you know, that was useful. Also, one other thing I just want to show you really fast on insert special characters. If you're trying to find a Greek letter like lambda, type in the name. It'll pull up a bunch of different fonts for you, okay? And it'll put that as soon as you click it. So let's do new. See what it comes up with. And so notice it has the ends. This is more of the new that I remember. The one that's in the font on my PowerPoint is not the best. Looks like it'd be for sure. Okay. All right. So what are you going to do? We've got a few minutes. So here's what you're going to do. You are going to get sent into a breakout room for 5 minutes, and you're going to try these top 3 values. Oh, one other thing I almost forgot. Remember, don't use the subtraction button for negative exponents. You want to do a negative exponent. Use this negative that's in parentheses. I think on the Casios, it's a plus/minus button, and it's on the left-hand side. But the negative button for negative exponents is on the bottom next to the enter button here. Okay. So, yeah, all of these have a negative exponent in them. So I'm going to put you in